All right, guys. If you're still following along in your table of contents, today we're going to take a look at 11.3, which is solving radical equations, meaning that we are going to be seeing that equal sign in our problems again. So you guys can add that in, and then we'll go ahead and add to our notes then. All right, and so like I said, we know that that word equation means that there's going to be an equal sign. So what we are going to be doing in this lesson is going to be isolating x, just like we've done before, and you actually saw that on your workbook homework from last week. So if any of you guys solved 22C algebraically, that's exactly what we're going to be looking at today. So really quickly, here are your two steps to solving a radical equation. Number one, just like I said, you are going to be working to isolate the radical. And so again, radical meaning that square root sign. So all of our problems, the x is going to be underneath that square root sign. So we need to make it free or help it break out of that square root jail here. All right, the second part of that then is going to be to square both sides. And again, what we do to one side, we want to do to the other side. It's that thing about balance. So to undo that square root, we are going to be squaring both sides. So we'll go ahead and take a look at some examples. All right, so let's go ahead and we'll start with this example. Let's say we have the problem 2 rad x, and again, what that means is 2 times the square root of x minus 8 is equal to 0. All right, and again, the objective here is to solve for x. Again, x right now is in that square root jail, so our goal is to get that square root by itself. And just like we've seen before, I know you guys know how to do this already, the goal is to get this by itself. So we're going to have to move over that 8. We are going to use our opposite operations. So we're going to add 8 to both sides. That's going to leave me with 2 rad x is equal to 8, or again, 2 times rad x. To undo that times 2, we're going to divide by 2 on both sides. And again, that's going to leave me with the square root of x is equal to 4. And so here now we're going to be solving for x. And our last step to undo that square root is going to be to square both sides. That's going to cancel that out. And so in this case, x is going to be equal to 16. All right, so not too bad. Something I know that you guys are very capable of doing. All right, if you want to try one on your own, I will give you a minute to write it down and then go ahead and try to solve that also. All right, and there is your final answer. X is equal to 1 over 16. How did you guys do? Hopefully good, right? All right, we'll go ahead and take a look at another example. A couple things that I'm going to point out to you guys is that as you guys see these problems, as you guys solve these problems, they actually do not have to be set equal to 0 like we saw with our quadratics. So for example, if we had a problem like this, 4 times, let's say, the square root of x minus 7 plus 12 is equal to 28. All right, so again, notice that you do not have to set this equal to 0. One other thing that's unique about this problem, though, is I want you to take a look at what's underneath the radical. Unlike our last two examples here, x was the only thing underneath that. This time, though, there is a number there, and so that is going to cause you to have an extra step. So just be very cautious. So we'll go ahead and solve this one together. All right, so same idea here. We are trying to get x out of that square root jail. So we need to isolate that term first. So first thing you're going to do here is move that 12. And again, we're going to do the opposite. So we're going to subtract 12 from both sides. All right, I'm going to bring this whole term down. So 4 times the square root of x minus 7. And again, be careful. That whole x minus 7 is underneath the square root sign. Is going to be equal to 16. All right, next step to isolate the square root is going to be divide by 4 on both sides. And again, now that's going to leave me with x minus 7 is equal to 4. All right, but please again notice that that x is still underneath that square root jail, so we have to break them out. And we know that to do that, we have to undo the square root by squaring both sides. So again, that cancels. We are now left with x minus 7 is equal to 16. And then just note, it's nothing too complicated, but this is where your extra step is going to come in, is now that you have to take that last step to isolate x completely. So you're going to add 7 to both sides. And when you do that, you're going to end up getting x is equal to 23. All right, so hopefully that made sense as well to you guys. We'll go ahead and take a look at some other examples that you guys will see on your homework. And then I think from there, you guys should be good. So last two. All right, so in our next example type that we're going to look at is a problem where we actually have radicals or square roots on both sides of your equation. So in this problem, we have the square root of 3x minus 7 is equal to the square root of x plus 21. All right, and the concept is the same here. We're still going to be looking for x. What you would do in this case, though, is actually you would want to get rid of the square root signs. And just like we saw before, if we square one side, so if I got rid of it on this side by squaring it, I would just have to make sure that I would do the same on the other side. And so that square term would cancel out that square root right away. All right, what that would leave me with then is going to be what's underneath the radical sign. 3x minus 7 is equal to x plus 21. And then from there you would solve. So it becomes variables on both sides here. So again, first step we saw was to square both sides. And we saw that that cancels out our radical or our square root sign on both. And then number 2 would be to solve. All right, so again, I'm going to go ahead and move the x's over to one side. 2x minus 7 is equal to 21. Move over that 7. 2x is equal to 28, or in this case, x would be equal to 14. All right, now last example. You guys are really going to enjoy this last example, I promise. So if anything, I would say write this one down so again, you have the knowledge of how to do it. We also have the vocab that goes with this problem. Square root of 6 minus x is equal to x. All right, so just like we saw in our previous example, we want to square both sides so that we can get rid of our radical. So we'll do the same thing here. So just like before, let's square both sides. And remember, the benefit of that is that it allows us to get rid of this square root here so that we can get x out of that square root jail. All right, so square both sides. What this leaves me with then is going to be 6 minus x is equal to x squared here. All right, so now our goal here is to solve. However, you're looking at this and you're thinking, there's a squared and there's an x. I'm not quite sure what to do. And I'm going to tell you that you know exactly what to do. So when we see this square right here, which is a little bit different from our last problem. So notice there's no squared term there. Likewise, notice there's no x squared here. What that means for you guys is this, is you are working with a quadratic. And lucky for you, you know how to solve a quadratic. So going back to last chapter, when you're using quadratic formula, when you're using factoring, it's back. So now you get to use those skills again. So what I will point out to you guys here is that if you have a x squared, it means that you have a quadratic. And it means you get to use one of your most excellent methods to solve for that. So what I'm going to do here is please remember that a quadratic is set equal to 0. So that is going to be our first step here. It's up to you which terms you want to move over. I'm going to go ahead and just move over the 6 and the x though to the other side. So that's going to end up giving me 0 is equal to this x squared plus x minus 6. So I went ahead and put that into descending order so that I can solve it. All right, again, it's gonna be up to you as to which method you would like to use. I will remind you of some of them. So we do have factoring. You could graph. You could complete the square. Or again, we can use quadratic formula. So that's going to be up to you. With this problem, just because of the lower numbers, I'm actually going to factor here. And our numbers here would be -6 and 1. And then again, just because of how low those numbers are and the relationship and the different values that multiply to 6, I can see that I would pick here 3 and 2. And in this case, I would add my negative to my 2 here. My factors end up then being x plus 3 and then x minus 2. So x being -3 or +2. So it is a good thing that you know how to solve a quadratic because you will see it here. But again, just watch out for that. So as I pointed out, soon as you see that squared term right there, you're gonna know that, okay, I have to use some sort of method to solve a quadratic. So watch for that. All right, so hopefully that made sense. Thumbs up. I have one last thing. It's not an example, so I did not lie, but I have one last thing to point out to you, and it has to do with vocab that you guys are going to be seeing in this chapter, or I should say in this section. So please note this word. You are going to see this phrase. All right, so when you guys do see this instruction set, check for extraneous solutions, you want to take that extra minute or two to go ahead and check the answers that you got. The reason for that is because what this is telling us is that there might be an answer that's not really a solution here. And let me show you what that means. We're going to go ahead and go back to that last example that we looked at. If you guys remember, the original problem was this. The square root of 6 minus x is equal to x. All right, and then the two solutions that we got when we solved this, the solutions we said were +2 and -3. And so what I'm going to do again, I'm going to go ahead and check those. So let's go ahead and check when x is equal to 2. So I'm going to plug that in here.
This would be the square root of 6 minus 2 is equal to 2. So go ahead and simplify that. 6 minus 2 is going to be 4. So remember, pretend like there's a parentheses around those values there. So solve what's inside first. Right? Square root of 4 is equal to 2 and 2 is equal to 2.
So what that means is that x is equal to 2 would be a solution here. It works in this problem. Let me go ahead and check the second one though. So in this case, our second one was x is equal to -3. All right, same idea. Plug it in.
So 6 minus -3 is equal to -3. All right, let's go ahead and do some simplifying here. 6 plus -3 is going to be 9 is equal to -3.
And then final answer here is going to be 3 is equal to -3, which is not true. So what this means is that this here is that extraneous solution. And so sometimes how you'll see it written is ES for extraneous solution, and it's a solution that does not work in this problem. And so again, that is one thing that you would note here. So it might say, what are extraneous solutions? In your final answer, you would say extraneous solution is -3. So again, it is a number that did not work in the original problem. I know some of you guys are thinking right now, well, isn't the square root of 9 positive and -3, Miss K? And you are correct when you say that. So one of the things that I stressed to you guys last chapter was that when we take the square root and we use that square method, that we want to have those two answers. And at the time, that should have made sense though, because we know that a quadratic typically is going to have those two solutions. And so that's why we would be looking for those two answers. What I want you guys to actually remember here is that when you guys are taking the square root here, unless noted, you actually only want to be taking the positive now. So take the positive square root. And the reason for that, though, is when we're solving a problem like that, we want to use what's called the principal square root, and that's always going to be the positive value here. So I know it's confusing, all these weird math rules all the time, but again, as you guys are solving, as you guys are checking for that extraneous solution, you are going to be using only the positive, so the positive value when you take the square root. So I know more rules, but just something to watch out for. All right, guys, that should be enough to help you through the homework. Let me know if you guys have questions. Bye, guys.